Hello, everyone. Welcome. My name is Inijo Matthew. I come to you from cold Chicago. It's 36 degrees here, nearly freezing. I am an associate professor at the Institute of Design at Illinois Institute of Technology. I graduated from BITMAA-NA in 2000 with a degree in architecture, and since then I've studied at Harvard University. I did research at the Media Lab at MIT, and my PhD is from the Open in UK. My research looks at how technology is transforming our cities, how companies and institutions can build resilient futures based on this change. Today, I want to welcome you to BITMAA's second webinar. BITMAA stands for BITMAA Alumni Association. The organization itself was founded in 2013 when a group of 63 batch alums in the US wanted to contribute back to BIT. And so they set up a 501c3 organization to help alumni give back to our alma mater. Before I start, I want to acknowledge the core team of BITMAA-NA who helped put this together, especially Sharath Tatapudi, who is pulling all the strings for technology from BITOSA. Also a big shout out for my fellow BITians in Bangalore, where they have the BITOSA Global Conclave. It was a great show, and it looks like there was lots of action happening there. Yesterday, we also had a great alumni meet in Atlanta. A shout out to my friends in Atlanta as well. Both of these are happening miles away, and many of us cannot attend them in person. So today, we have this webinar for those who cannot join these things in physically. So what is BIT Munch? The Munch is a forum where we invite successful BIT BESRA alumni to talk about their journeys, their successes, and their failures, to talk about emerging trends and technologies that they're working on. Today, we have about 150 people who have registered for the webinar. We'll get to Gurdeep Pal, who is our speaker, very soon. And as soon as he speaks, the focus will be on him on YouTube Live. But before that, I want to set up the expectations here. What we'll do is, Gurdeep will start with a presentation. We'll run about 25 minutes, and then we'll open it up for questions. During this time, I encourage you to start pushing questions to live chat. What I will do is I will collate those questions and then ask them to Gurdeep. So I'm going to ask them on your behalf. If you have follow-ups to some of the things that Gurdeep is answering, you can post them to live chat as well, and I'll do the same thing. So let us start. In the 1980s, a new force started to shape our world: digital. Soon afterwards, it was joined by its cousin, the internet. Together, these two forces radically reformed our world as we know it. Entire industries and institutions were destroyed, and new industries and institutions grew in its stead. Today, we are seeing the rise of two new forces: artificial intelligence and blockchain. My prediction when I speak to my students is that these two forces will have radically more impact than digital and internet. But we are at the beginning of that transformation. And we'll see change like we have never seen in human history. To speak about this, we invited our guest today, Gurdeep Pal. Gurdeep is an alumnus of BITMAA-NA. I've only talked to Gurdeep virtually, but even when I speak to him on the internet, his insights and authority on this subject is so impressive that I thought it would be great to speak to him today. Gurdeep is an 87 graduate from BITMAA-NA in computer engineering. He is currently the corporate VP for business AI at Microsoft. He joined Microsoft in the 1980s and has gone through 3 decades of change. In the first decade, he founded the Windows NT operating system. He was one of the founding members of that team. The next decade was real-time communication and Skype and Teams and so on. He has this wonderful story, which we'll get to in a second, where he made this sort of impressive presentation on stage that showed the world the power of real-time communication. This decade, he's focused largely on artificial intelligence, or AI. Gurdeep has an executive MBA from Wharton, and his master's is from the University of Oregon. He comes to us from warmish Seattle. I think it's about 47 degrees there. So over to you, Gurdeep.
Thanks, Anijo. This is it's really an honor to be here talking to my fellow BIT friends. You know, it's a little over 30 years ago that I left BIT, and it's been a really fun ride. But having I will say that I look back at my days at BIT very, very fondly, as I'm sure most of you do. But after BIT, and thanks largely because of how I was prepared by BIT, I happened to sort of time it right where the whole sort of technology era was sort of kicking in. And it's been an incredible 30-year ride for me in this industry. And I'm very happy to share, some facets of it, especially what's really happening right now, with the broader group. A bit through my presentation on AI, but also after that in the Q&A, as things lead us there. So again, really an honor to be here. So let me go ahead and get started with the presentation, and then of course, we can take this wherever we want to take it. So let me just share my screen and. I hope you can see this. Yes, is that, can everybody see it?
We'll be able to see in a second, Gurdeep. There we go.
Okay, great. So the topic I wanted to talk to you about today is really AI. I'm sure you've heard about artificial intelligence, but hopefully by the time I'm done with this presentation, you will look at this.
Yes.
Okay, great. So hopefully, when I'm done with this presentation, you will look upon AI as an incredible opportunity, and that regardless of what discipline you're in, that you will actually, learn more about it and figure out how this can help your careers as you move along. So the thing I will put forth to you is that AI is really the fourth industrial revolution. Okay. Now, this isn't just one of those grand statements. So let me go back a little bit in history. The first industrial revolution happened because of steam and steam engines, and this is what really created the factories and sort of the industrial era as we know it. And then, about 100 years after that, electricity, as that became pervasive, it started changing lots of things and created new opportunities. Another 100 years or so after that, you saw the microprocessor and sort of the computer era that we're sort of living in. We are now entering the fourth industrial revolution of artificial intelligence. Now, why this is important? Well, firstly, the kind of change that we are going to see in the next 10, 20, 30 years is of the scale that was seen previously, when the industrial era kicked in with steam engines, when it kicked in with electricity, and it kicked in with computers. And that is something that we really have to take a step back and internalize, because it is not just about technology change. This is about societal change. It is about, governments and policies and trade. Everything that we know is going to go through a fundamental change. And the more we approach it with that stance, I think the more successful we are going to be as we get into the fourth industrial revolution. But before I get into even talking more about AI, how did we get here? So let me start with a bit of a narrative, because AI itself is it's 13th century. There was a philosopher, Roman philosopher, a Spanish philosopher called Roman Lull, who first envisioned the notion of intelligence existing outside of a human. So it's almost you could argue 1,000-year-old idea, but why is it that now we are really talking about it? So this story actually starts back in 1965. This is Gordon Moore, who really was one of the founders of Intel and the creator of the microprocessor. And in 1965, he made a statement that every year, every 2 years, the computing power is going to double. And that observation was based on the microprocessor and how many transistors that you could fit into the microprocessor. And of course, in 1975, since 1975, it was more 18 months is what they say that you will have computing power double. So what that led to was in 1995, when Windows 95 shipped, which is considered one of the most popular broad operating systems, they were about 5 million 5 million transistors on a chip. Okay, 10 years later, there were 160 million transistors on a chip. In 2010, around that time frame, we crossed the billion transistors on a chip mark. Okay, so this sort of gets you a sense of how computing power sort of advanced. And then in 2015, there was one chip, there was one transistor per every human on the earth on one chip. 2 years later, 2 years later, sorry, the animation may be a little slow. We actually doubled that. Okay, so in some ways, Moore's law, which talked about computing sort of going up, and that actually held till at least last year as we know it. Okay, but now we are coming to a very interesting point. We are at what they call 5 to 6 nanometer fabrication technology for transistors. Which means that we are roughly about 10 to 15 atoms wide in terms of the wires that are required to make transistors. So it is very clear, if you do the same math of 2x multiplication, that in a couple of years, we are going to run out of the ability to put more transistors on a chip. In fact, Gordon Moore himself, he's a grand old gentleman now. He made a statement that Moore's law will run out in this decade, and he's right. So the only way, if you're gonna, if you can't really squeeze in more wires because you're hitting the atomic limit, the only way that computing can really progress is when you look at quantum computing. My talk is not about quantum computing, but this is one thing that this will play a very important part in your lives if you're entering into you're in college today, or if you're just entered I will be long retired. I don't need to worry about quantum computing, though it's fascinating. But you will really need to worry about it. Why this is interesting? So you're going subatomic at this point, right? Let me share one number with you. If you look at the 2048 RSA crypto cracking problem, which is largely based on factoring very large numbers. On classical computers of today, it takes 1 billion years. On a quantum computer, it takes 100 seconds. Okay, this is so dramatic that NSA and all the security agencies are now looking at post-quantum cryptography, sorry, which is that if you have content which has been encrypted using classical methods, which is the classic factoring of large numbers, they are now starting to take all those secret documents and encrypting them in a way that quantum computers can't crack them in 100 seconds. And we are really in the advent of this quantum computing era. I won't spend more time talking about quantum computing with you, but turns out it is quite synergistic with artificial intelligence as well, because in many ways it is a statistical computing medium. So if you can map the problems that you're trying to solve into quantum computing algorithms, you can actually solve them very, very fast. So let's get on to AI. Now, what you see in front of you is really the last 4.5 billion years of the Earth, okay, since the Earth was created. And you're looking at all the different periods. About 4 billion years after the Earth was created, we entered a very fascinating period called the Cambrian acceleration. Okay, what happened in the Cambrian acceleration is that there were all these living forms which were very, very small. and they were starting to look for food, and they were, sort of banging into each other, and food was, scarce and so on. But then something very interesting happened, and scientists still debate this heavily. But what happened is that they believe that some of these living forms developed ability to see, vision. When they could see, it created a acceleration in development of these organisms, because now if you could see, you could seek out food much more easily. You could seek out other organisms that may not have vision, and you were able to develop, you were able to get to food better than them, so you were able to get a lot more successful, and then you were able to ward off predators and so on. So this is called the Cambrian acceleration. We believe that we are now entering the AI acceleration, because we now have found the ability to augment intelligence. As we are looking at everyday tasks, we look everything from life to work and in between, we are now able to apply artificial intelligence to make that lot better. So this is the context in which the fourth industrial revolution really is coming to us. One of the biggest breakthroughs that has happened in artificial intelligence is really this area called deep learning. Deep learning, in some ways, is not a new idea, because it is based on neural networks, which actually were first envisioned, almost 50 years ago. But only in the last 10 years, we were able to get the right amount of computing power, thanks to the development of, the microprocessors and the progression of power that is there, that we were able to actually get that much computing power to make neural networks work, actually just work. So, what you see here is as a deep learning, deep neural network machine learning system. In the middle, you give it some English training data, and it is able to understand English with certain amount of error rates when you input it. If you give it more data, it gets better with fewer and fewer errors, okay? Because this neural network is able to basically learn the patterns that are there. Now, what is interesting is that when you give it French training data and English training data, both French and English improve better than what they were if you're just trained on one of those languages. So you take pause and you say, what is common between English and French? Well, it turns out that that these deep neural networks are able to find patterns that humans are not able to even express. And this has been the biggest step up in artificial intelligence since the previous era of artificial intelligence. See, in the previous era of artificial intelligence, there was a presumption that humans can teach the machine what they want the machine to learn. But now we are realizing that the machine can actually figure out a lot more than what humans can figure out about these patterns. And that is where a lot of this magic is starting to happen with artificial intelligence. And frankly, it's literally in the last 10 years or so that we've seen this huge step in deep learning applied to lots and lots of problems. Before I talk more about AI, I want to say, a lot of people confuse BI and AI. Okay, BI is not AI. AI is not BI. Business intelligence, which some of you might have heard about, is really about really processing the data and presenting it to the human so that the human can make sense of the data. Okay, artificial intelligence is where AI can actually look at the data and actually figure out what it is and automatically take the actions, rather than the human necessarily being in the loop on some of those things. So that's sort of an important grounding I found, because a lot of people think that BI is AI and so on. They're actually quite sort of different. Now, some people say that BI set the stage for AI, and I would probably agree with that, because a lot of the digital transformation and getting data into a form where you could then visualize it became sort of a necessary but not sufficient step in the artificial intelligence algorithms than working on it. So, we've talked about computing, but there are really three constructs beyond, on top of just basic computing power, I think, that have enabled AI. One is data. See, digital transformation, which frankly we're still undergoing in some ways in many parts of the industries, it did one very important thing. It actually brought all these analog artifacts into the digital domain, and whether they were structured or unstructured data, it was at least available in a place that you could now get access to it with algorithms. The cloud computing, where you can literally harness, hundreds of thousands of cores, very, very quickly, became very important in training, especially with things like deep learning, in training a lot of these algorithms. And then lastly, because of deep learning, we've seen tremendous step up in performance on basic capability of intelligence, things like computer vision, speech processing, language understanding, etc. And a lot of that has happened because of the confluence of data, the cloud, computing power, etc. And of course, as I like to say, this capitalism is wonderful. As there's a lot of money at the end of it, and people realize that you can bring these assets to bear to improve the performance of these business problems. A lot of ingenuity sort of goes towards improving these algorithms, and we are really living in sort of the golden era of these algorithms right now. Just to give you a sense with deep learning, and these are like Microsoft AI breakthroughs. Some of these happened in my group itself. 2 years ago, we surpassed human ability to recognize objects. So there's a ResNet vision test where you can basically, it's a benchmark that is there for anybody to sort of compete on. Using 152 layer a deep neural network, we were able to surpass 96% of object recognition. This is where there's many objects, and you got to see which one of them, how many of them do you recognize, and recognize them right. So we surpassed human level of computer vision 2 years ago. Last year, we surpassed human ability to do speech recognition, which means that if a human is sitting and transcribing, and AI is also sitting and transcribing, the AI is able to transcribe better than humans. In fact, 5.1 was better than experts. I think 5.7 was normal humans, 5.1 was experts. Machine translation, which is again a very, very tough task between one language to the other, we surpassed human parity on that. And then my favorite, this was in my group last year when we first, earlier this year, when we first surpassed it, AI reading text, understanding text, and then being able to answer questions on the text, we achieved human parity on that. This is super interesting. So literally, you can have the same algorithm read a medical document, read a legal document, read Harry Potter, and then you can ask questions, and it is able to answer these questions with a very high level of precision, again, to human parity. In fact, now we are, this test itself has been upgraded. There's something called Squad, which is the Stanford Q&A data set. That has been upgraded to V2, which has a lot more inference-based sort of questions. And now the race is on to try to, again, surpass human ability there. So just giving you a sense, all this has happened in the last 2 years. And so the pace of change of AI has been mind-boggling because of deep learning. We see AI evolution is going to continue, where it's come from an old way of rules-based to search-based. I think now we are in a lot of these integrative methods where you can apply different forms of deep learning. You can combine it with other types of processing. And because of that, you are able to do, of course, crack important things like AlphaGo, which you've probably heard about, where the Go game was beaten by these algorithms from DeepMind. Self-driving is really even people don't laugh at it when you say that we're going to attempt self-driving, which is like level 5 autonomy, where a car is able to navigate all situations by itself. That is in the realm of the feasible. And frankly, we are really entering an era of autonomous systems, which in some ways is the hardest task for AI systems. I always joke that if you want to befuddle anybody who claims to know a lot about AI, you tell them to build a machine which can fold laundry, and everything sort of breaks down there. But I think we are coming to an era where you will see robots folding laundry and other interesting tasks as well. But that's sort of the evolution of AI that we're in. In terms of, what are the patterns for AI solutions, how AI can be applied to real world business problems, you're starting to hear about bots a lot, but I think, frankly, many of them are not very capable today. But we are entering an era where just the way you used to have IVR systems where you called into a business and you basically navigated, by punching in numbers on through the menu, you're going to be interacting with agents. This is imminent. Multi-turn conversations are starting to happen with these with AI. I think you will see in the next 10 years, you will not be talking to humans in the same way, you don't talk to, with IVR systems, you can resolve things by yourself. So this is going to be a very, very big pattern to watch for, even though some of the early, examples are not very impressive with all these bots and so on. The second area is what we call ambient intelligence, is the ability to actually understand, to watch and understand what people are doing. This is massive. Like whether you look at manufacturing, whether you look at retail, whether you look at office space, etc. If you can actually understand what is happening in the world around you, you can now create workflows and rules and policies and stuff like that. In this example of this picture, the fact that on a manufacturing floor, a pipe was there or a spill was there, you could imagine the using computer vision and sensor fusion, that is detected and automatically a workflow kicks in, and there's an alert which is sent out that, listen, there is an oil spill in this part of the floor. And automatically, you can even imagine a drone which flies in and hovers over there with flashing lights so that nobody steps on it. Similarly, some of the scenarios you're seeing now with Amazon Go, where you can walk into the store, pick up a product and walk away, and you get billed for it automatically. All these are kind of things that are now becoming feasible. In AI-assisted professionals, everything that whether it be in finance, in marketing, manufacturing, legal, healthcare, is going to transform. We're already seeing not one, but many, many, many examples of AI being able to understand medical imagery, being able to detect cancers, being able to detect eye conditions better than expert doctors can do that. So you should expect this is just going to become the norm. Understanding documents, understanding video content, this is really starting to happen. The idea of converting data into knowledge and being able to reason over it is one of the big things that even the machine reading and comprehension stuff I talked about earlier is really enabling. And then lastly, autonomous systems, which is in some ways the hardest of these problems. Now, you've probably heard a lot about some of these other areas. You've seen bots, you've heard about Amazon Go and other things. On autonomous systems, you probably haven't heard as much other than the promise of self-driving cars and so on and so forth. So I thought I'd talk about some of the work that is happening in my team. This is some work started in Microsoft Research, and now we're spending a lot of time on it. Is that we can actually model in a photorealistic way entire environments. This is some of the stuff that's been happening in gaming, but we've taken a lot of that tech and capability. You render all this in a photorealistic way in a virtual environment. But then what you do is that you model the sensors also inside that environment. So imagine that not only you have this environment that you can navigate through, drive through, and so on and so forth, but you can actually put in virtual cameras, whether it be video cameras, you can have LiDAR, you can have radar, you can have other sensors, temperature sensors, etc. And now you can get the data directly into the sensors and train your models directly inside this virtual environment. So you've created a pretty much intact alternate world in which you can perceive and train models and become intelligent. Because once you can do that, you can take these models and actually put them into the real objects which are operating in the real world. And you can now train these things so much more efficiently. Because imagine if you're trying to train a drone to inspect a power line, that the amount of hours it'll take, the amount of, not hours, I would say, you need hundreds of years of data to actually train it properly. But we are able to now do that inside this virtual environment. This particular project, by the way, if you're interested in, it's available on GitHub. So if you are interested in dabbling with the autonomous systems, this might be a good place for you to get involved in. one particular application of autonomous systems, this is also with my group, it was recently written up by Wall Street Journal. um, Shell uses these horizontal drilling machines, and it takes a lot of expertise to guide these drilling machines. We were able to train using reinforcement learning models, which can operate these drilling machines without the expert being there. And we did that using simulation and training with reinforcement learning. In fact, the CTO of Shell is quoted in this Wall Street Journal article, where he said that we have a self-driving drilling machine. And these machines are really expensive and big. As you can see, they look like howitzers. They cost a lot to operate daily, and if they get stuck because we were not able to navigate it properly, that is a huge loss for for Shell. So this was one of the very successful AI projects. So so what's next with AI? I mean, a lot is going on. The amount of research, the amount of both in academia, but also in the industry. There are lots of interesting paradigms. There's something called machine teaching, which is focused not so much on the algorithm being able to learn and find the patterns in the data itself, but it's focused on how an expert is able to transfer their knowledge. A human expert can transfer their knowledge to AI systems. This is an area that my team is spending a bunch of time on. Causal inference is a pretty amazing thing. Some of the Nobel laureates and Turing Award winners in AI are actually spending time on things like causal inference, where given a particular event, you can actually predict, you can tell what other things led to that particular event happening, which is, as you can imagine, is a very, very hard problem. Imitation learning, where AI can actually observe when what is happening and then learn from it as experts teach it. There's model-based reinforcement learning, which is again a very has a lot of potential, because rather than learning every problem from scratch, you can the way humans, and by the way, that's something I should mention, that most of AI today is inspired by observing the human mind. So the study of the human mind, and how we are able to construct these neural networks inside our own biological brain, but also the efficiencies on things like Hebbian learning, etc., that the human body basically is able to do. How you can frankly model that in an artificial synthetic way. So humans are able to, if they see one ball bouncing, they are able to learn that, hey, this ball actually has a property where it squishes when it hits the ground, and then it bounces up again. So the next ball that we see, we kind of don't need to learn that, oh, is it hitting the ground and bouncing? But similarly with AI, we want to do this model-based reinforcement learning, where if it looks like a ball, you at least have some initial idea into how it will behave. And then the holy grail is something called artificial general intelligence, where the idea is that today artificial intelligence is very, very task focused. But if we can generalize that, we can really start emulating the human mind, because human mind has amazing ability to generalize. So that's kind of my brief talk. Actually, before I wrap up, let me talk a little bit about AI ethics. There is a lot of concern in the world today about AI, and I think some of it is well founded, in the sense that we cannot enter a Wild West era in the fourth industrial revolution. I think we have to pre-think on how we want the AI to be in the world around us. If the purpose of AI is to serve humans and make the lives of humans better, you have to sort of get ahead of it. So this is an area we're spending a lot of time on ethics. I think Anijo will probably talk more about this with me, but we have some principles that we are really trying to be not only embrace them ourselves, but also influence governments, policymakers, etc., on how AI ethics should be dealt with. So free advice for you that you didn't ask for. Anijo would probably have me add, blockchain as one of the things. If you're entering the workforce today, or most of your work life is ahead of you, or if you're in college, there are three trends I will raise for you. Mixed reality, which I didn't talk about today. I think you're going to see a complete change in user interfaces and how the virtual and the physical, the virtual and the physical world actually interact with each other. Artificial intelligence that we talked about, and quantum computing that we touched on briefly. So I would, and of course, blockchain. I would make sure you spend a lot of time understanding these things. So that's pretty much my talk. I will now pause the sharing, and we can get into Q&A.
Thank you, Gurdeep. That was fantastic. So let's start with some questions that I got from the crew, the people who are watching this. And some of these came from registration data when they inputted, and some of it came from right now on live chat. Okay, so why do we still use the term artificial intelligence? It seems like intelligence itself, like you said, during the Cambrian acceleration, is emergent property of systems, regardless of whether it is biological or otherwise. This comes from Aaron Cook.
Yeah. So, the thing I would say is that people have talked about whether we need a new term, which replaces artificial intelligence. I think maybe synthetic intelligence is a better way to talk about it. But we certainly want to make a big distinction between what is biological intelligence and what is synthetic intelligence. I think if nothing else, even when it comes to governance and rules and policies in the future, I think we will want to have that very, very important distinction, because the rights that we might give to humans and their intelligence may be very different than what we put to synthetic intelligence. Because frankly, we are going to enter an era, and you're starting to see companies like Neuralink, etc., from Elon Musk starting to come about, where you will see systems that are actually augmenting the human intelligence and artificial intelligence that are actually literally bonded in the human brain. And this brain-computer interface is a whole fascinating area in itself.
Singularity.
So you want to have some term that distinguishes from biological intelligence, whether it be synthetic intelligence. Probably it's more maybe it's a better term than artificial intelligence.
Yeah. So if you took the human brain as datum, like for example, in autonomous driving, you have the levels, right? The 5 levels of autonomy. Is a conversation at Microsoft about how different levels of artificial or synthetic intelligence can be expressed with the human brain as the data? So this comes from Ellen Patnaik.
I think it's a really good question. I don't think the taxonomy of the level 5 driving, level 1, level 2, level 3, level 4 has actually been mapped into how you can look at other intelligence problems as well. Though it's not a bad model to really think about. If even let's look at speech recognition and the whole stack of really trying to understand something, right? We talk about the ear, then we talk about the part of the brain that actually is able to convert those analog waveforms converted into electrical signals and into something that the rest of the brain can actually deal with. So you could say that some of the sensors and basic beeping when you're too close or something is maybe analogous to that. But then truly being able to understand what is happening is the next layer. And then being able to take action based on what you understand becomes the next layer. So you can see how you can start to map those things. And certainly we are seeing application cases in each one of those layers today, whether it be in computer vision, whether it be in speech. So yeah, I think there's a mapping. We just haven't done it that way.
Yeah, so this leads to my next question, is in like the most common way that AI manifests in my home today is through conversational interfaces, right? So you have Alexa, you have Cortana. For right now, I have Alexa and Cortana running simultaneously on my machine. But then I also have Gmail making predictions on how I might respond to my friends on email and so on. So on this scale that you're talking about, what are some of the ways that we might actually see AI manifest for an everyday person? So just to make it even more complicated, how will it affect a laborer in India, let's say?
I think the 2 or 3 things I would want. So to a laborer in India, I think what I talked about ambient intelligence, I think will be probably the first the first way that they would experience it. Because the thing with ambient intelligence, it's really a very, very interesting and hard problem. When we did the model of what it takes to make an ambient intelligence solution work, it was more complex than Windows NT. Which is one of the large projects, engineering projects ever taken on. Um, but the thing with ambient intelligence, the premise is that the humans do not change how they do what they do. Okay. And it's the system has the burden of understanding completely what the system wants to understand from that observation. So the presumption is that really you can be the most non-digitally engaged person, but we are still able to provide AI can still provide value to that scenario. So if a laborer is carrying something and something falls, we can detect it. We can even pick out if a laborer has had a back problem and they are trying to lift a heavy object. We can actually detect, we know that laborer, we know that they had a back problem, we know the weight of the object they're trying to pick, and we can flag it and literally beep at the point where they're trying to pick that up. So there's a whole bunch of interesting scenarios like that. One of the ambient intelligence scenarios we talk about a lot is that imagine in a surgery, this ambient system is observing all the things that are going on in the surgery. And there have been cases where people have left instruments inside of the human body, or the process was not done correctly. They can literally be watching and saying, no, beep and say, no, you need to do this. You don't do that. You left this. So I think those are the kind of scenarios I can think of.
So what you're saying is that the actual manifestation or the instantiation of artificial intelligence might very much be like the ubiquitous technologies that we've had in the past, like electricity, which sort of works in the background. We don't see it.
Exactly.
Yeah, okay.
Exactly. And I would just, if I can belabor this a little bit. See, if you look at computing and the third industrial revolution, see, it started with the presumption that the machine is not smart, the human is smart. So let's train the human on how to interact with this machine. And we created the keyboard, we created a mouse, we created all these sort of metaphors, with the desktop and so on and so forth, really with the idea that, the human is so smart, it'll figure all this stuff out and it'll get what it wants done out of this machine. I think in this industrial revolution, you're going to invert it. The machine is going to become really smart, and the humans can do what they want to do in their own way. They can speak their own language, they can express intent, they can be forgetful, they can have they may not express the context fully, but the machine can figure all that out and really help the human. So it's sort of, that's kind of one mental model.
Right. So go ahead. So this goes to the next question. And we've had, of course, as you can imagine, there's several people who are concerned about this, right? So we have Ramesh Gupta, Ashok Krishnamurti, Harsh, all of these folks asking the same question. Why are we pushing back on AI adoption, right? So how do different societies view AI and its impact on the human race? For one, for example, we just talked about this before this presentation, is that different societies view intelligence, synthetic intelligence, differently, right? For the Western culture, it's killer robots that will enslave us and bake us into batteries, right? And for the Japanese, it's a way for the technology saved them from the cruelty of humans. So this, can you conjecture on some unintended consequences? For example, the loss of jobs, the impact on factories and manufacturing environments and things like that.
Yeah. So let me start by saying that, this is an area where you can't be flippant about it in either direction. You can't say, let's go free for all Wild West. And at the same time, you cannot say that, let me shut down everything and, go take the Unabomber lifestyle in Montana or something. So you have to approach it in a very thoughtful manner. Last year, for the first time in my career at Microsoft, I had an economist and an ethicist reporting to me, because we wanted to pull forward a lot of the issues. And these weren't, these abstract issues. We were literally having customer conversations about these issues when we were taking some of our more complex solutions in front of them. So I believe that this is an area, it is going to happen whether we like it or not. We cannot, this is not going to be like, I'm going to go into what happened in the 90s, sorry, in the last century, even in India, where we said, I'm going to go into a closed economy and I'm going to shut down everything around me and everything's going to be fine. That lasted for about 30, 40 years, and then turns out things weren't fine and we had to deal with it. I think this is imminent. It is going to happen. If it is going to happen, it is best to lean into this and say, how do I make sure that this thing is working in the in improving humanity and advancing humanity, and not in destroying humanity? We dealt with that. I mean, in the nuclear era, we dealt with that. We've created a detente, or whatever you might call it, where we are able to deal with the fact that there are nuclear weapons in the world. And but it takes a lot of work and it takes a lot of leaning in. So if there is ever um, if I have one concern, it's actually not about AI. It is about what is happening in the geopolitical climate around the world today. I mean, we are regressing in our dialogue in how we can advance society and create the right kind of policies, etc., rather than advancing. And if anything, this calls for just rapid policy work. I mean, you looking at, everyone is worried about, first we were worried about privacy because of Google and so on and so forth. Then we were worried about, our political systems being interfered with because of Facebook, etc. It's all reactive. I mean, this thing, we knew this. We knew this 10 years ago, 15 years ago. And these issues were raised with the government, and nobody did anything about it because our government is more worried about, preserving their political viability and so on. So, these are really serious matters. Interestingly, after the first industrial revolution, uh, there was something they call Engel's pause. Engel, as you know, was one of the philosophers who inspired Karl Marx. And it's called the Engel's pause because for about 40, 50 years, the economy actually didn't take off. It actually went down
Yeah.
globally. And the reason it went down was because training and the policies and rules had not yet actually kicked in to actually make this so that it was going to serve humanity. I think we're going to see the mother of Engel's pause coming up with AI if we don't get our act together on it. Certain governments are starting to do some interesting experiments. I think it's at Finland, which did this experiment with universal basic income. Unfortunately,
Mhm.
they shut it down recently, but I think we have to think about it. Either the workforce is going to be trained to take new kinds of roles that AI offers today, or they will need to be supported at a level which looks a lot low, like these socialist sort of policies, than what we are comfortable with in many of these countries. And I haven't even gotten into some of the more cultural aspects, which are, I think, even more nuanced. You talked about Japan. I think there's a reason why they have that sort of mindset towards technology, and it has sort of become pervasive in their culture. Whenever I get too depressed or feel that God, how is this ever going to correct? My only hope is the young people.
Yeah.
You know, every time in history, it is the young people who have saved us, and I think it's these folks. They have a much better handle on what these things are, their ability to reason with them. They are not beholden to thinking models, etc., from the past. So anyway, that long-winded.
Yeah. So Gurdeep, it's interesting you brought up the Engels pause, but then one of the things that happened during that pause was the old people who were coming from the pre-industrial era, their way of making money was actually selling gin in cards. And so alcoholism became a big part of the Engels pause. So people were drinking to drown out the sorrows of these things taking over
Yeah,
until the factory looms started to come up, right? So the younger people realized that, oh, yes, we can engage these people in actually making stuff, right? So then this was a very interesting thing that you bring up. So
fascinating, fascinating.
similar question. So this is Nikhil Kumar who asks, when PCs were introduced to our parents' generation politicians, it's like taking this whole new technology and giving it to someone who's familiar with typewriters,
Mhm.
right? How do we actually present AI to policy leaders and businesses? What are some of the challenges that you think will come up? Vishal Bhardwaj asked this question as well. What are some of the things that new startups need to think about when we think about AI and policy and business?
You know, it's a pretty complex question. There are many things that we can think about, we can pre-think, right? So, for example, um, if you if the system that you're designing has a particular function, it has to be able to perform that function in the context of the society that is around it. So, for example, biases, right? Let's say I've got this really great example. I'll come back to the main question. So, one of the teams when I was in my early days of AI earlier this decade, um, we built you see the Xbox Connect, where you could use your actions and so on. You probably remember that. So my team I was running Microsoft Speech at the time, so a lot of the speech recognition work that went into where you could give commands verbally, because there was no mouse or clicking thing. So it was either gestures or it was what you speak. So we actually created an entire interface in Xbox which was speech driven. So you would say something and then the screen would then show you that, and then you would select the next action and say, show me all movies with won an Oscar and had this actor. So all that work was going on. And I remember when I first installed it in my home, my older son, who was I guess he was 8 at the time, he basically would get up and he would give these commands, it would work. And my younger one, who was 5, tried to do the same thing and it didn't work. And I had this huge sort of a crying episode at home, because the younger one couldn't make the machine do what the older one could make it do. And I went back and we found out we hadn't trained our speech models to understand kids' voices. So the point there is that whatever your device is purporting to do, it should be able to do that and serve everybody equally well, etc. So there's things about biases that are inherent to training of AI systems. There is the behavior of AI systems has to be pretty transparent and understandable, and there has to be policy and rules and systems around that. Like, I'll give you one example. We have a committee called the Ether Committee inside Microsoft, and we're really focused on AI and ethics. And one of the things which we've really adopted is this notion of data sheet for the data that is used for the training of models, because that construct becomes a point of assertion of what your model can do and what it can't do, right? So biases can be, so, oh, you didn't train your data sufficiently, therefore it is not performing properly. So if imagine that you cannot sell a product unless the data sheet for the models is all there, right? That becomes a very important construct in the overall thing. So similarly, statements around, hey, is Alexa going to be listening all the time, or is it only going to listen when I say Alexa? So transparency around that behavior, explainability. So if you get recommended, so suddenly you're sitting and watching a movie and Alexa says, let me, I have a special on, guns for you. Hey, why did Alexa say, well, just because I'm watching these war movies or something, Alexa suddenly says, I want, special on guns for you. So Alexa is being held accountable and having some level of explainability on why it said what it said. So I think there are things like that, but this year, again, getting into rules and policies and things which we need to get ahead of rather than being run over by, as capitalism encourages so much innovation in this space.
Yeah. So we have a question exactly on this by Sumesh Kumar, who says, can AI discern human psyche instead of being dispassionate, right? So an example of this, like you said, Alexa forming guns. There was a recent episode where a Target recommendation engine made a recommendation to a person saying that looks like you are pregnant and you should buy maternity clothes. Mm-hmm. And this guy, the father, was like, wait, my wife isn't pregnant. It turns out his daughter had used his account to look for pregnancy, and he didn't know that his daughter was pregnant. So this is sort of this this relationship problem, this dispassionate relationship problem, when machines don't understand the human psyche, sort of thing. So you have, yeah, go ahead, sir.
Yeah, no, I mean, these are all, great questions. And I think they're in some ways maybe even be slightly different questions. So um, I think today we're still going through, what I call the transition era, right? We're transitioning from the old way of doing things. See, in the old way, like I said, the humans have to adapt to how the machine works. And in the new way, the machine adapts to how the human works. So in the new world, this is not a problem at all because the system would know who is interacting with it. So the context, etc., is really preserved. The problem is here you have somebody using an account belonging to another person. So the old world system, basically is now confusing who this is for. So I think I would, that particular example, I would say is more an artifact of that. I think the psyche one is a great question. It's almost a philosophical question because, even humans don't know what they want, right? When it comes to some of these things. Like if you see what is happening in American politics today, I mean, part of the problem is that we have humans who are subscribing to, not actually intentionally, they by using Facebook and Twitter and stuff like that, and because the algorithms are tuned to serve your point of view, they're getting caught in this groove where whatever they want to hear, they're hearing more of, and when they hear more of it, they want to hear more of it. So you develop these very polarizing points of view, when in reality, if you look at nature inherently has diversity, and you get diverse points of view, you get exposed to diverse points of view, and one day you might suddenly change your mind about something. But the way these systems are being built, they are actually really feeding off of that. Now you could say, well, if it wasn't for these systems, humans would only be buying newspapers which presented their point of view, and that is true. So humans themselves actually have this inherent bias, sometimes called the confirmation bias, etc., which basically says, just whatever, whenever I'm right is what I want to hear more about.
Right.
So you create this thing. So I think, but having said that, AI actually has the ability to counter this in a really, really good way. It's just that it is not economically interesting to Facebook and Twitter. Sorry, I don't want to go off on these companies, but it's way more interesting for them to make money by leveraging this model. For example, there's a field in AI called reinforcement learning. This is an area which I'm spending a lot of time on right now because most autonomous systems are actually built best with reinforcement learning, not with supervised learning, etc. So in reinforcement learning, there is a mathematical model on how you can explore beyond what the policy says. So you literally can specify, depending on the use case, this sort of epsilon. This epsilon is a number that basically says you have permission to explore outside of what you know, with the idea of broadening the learning. So, which is useful in so many ways. But as you can say, in a real world situation, you can only basically train a system on foreseen things, but there are many unforeseen things. A fish which fell out of the sky and fell on top of the screen of your car, I mean, could never train on that. But if you have a learning system that can actually explore and keep getting smarter, that actually works very well. And you could argue that's kind of how you want to really engage with humans as well, because naturally that is how they are, versus in this artificial environment where they're being exploited and so on and so forth. So it's a very philosophical topic as well. And I think, but these are the really important questions and dialogues that we need to continue to have.
Yeah, I mean, this is something very interesting, right? I mean, it seems like the human brain is somehow incapable of mapping clearly defined scientific knowledge, even though there's evidence presented. Whereas synthetic technologies start off with the premise that clearly defined scientific evidence is the starting point for these things, right? So there's some sort of meeting point where these things will happen. So I have a very interesting question, which I think Microsoft is dealing a lot with. And so we need to know a little bit about what you guys are doing about this. So Pranjal, who is a 22-year-old, asked this question. And can you imagine for this young person, this is important. What is Microsoft doing to use AI to face the challenges of climate change?
Mhm.
Right? So how is um, problems that will face human beings, but our brain is so small that we cannot perceive these changes.
Yeah. So, let me start by saying the right now there are few things that we're making sure that our cloud platform is available for a lot of these particular explorations. One area where not Microsoft directly, but Bill Gates recently is really starting to focus on climate change. This is an evolution in his own thinking, by the way. I had a chance to discuss some of these topics with him actually about a decade ago, where he was focused on education and healthcare uh, primarily, but not so much on environment. But now he's really focused on it. I think there's a couple of ways to think about it. I think one is what AI can help you with, and then what more information do you need to really make sense of what is happening from a climate change perspective. I think the climate change models are very, very complex models. In fact, the only I think the only application for mainframe for supercomputers right now is actually weather prediction. They do some other, actually I shouldn't say the only one. There's some other stuff they do in financial side as well, but this has been a big, because it's a very, very, very large complex computational model that they're trying to solve. um, Quantum computing has a lot of potential there, incredible amount of potential, because all those supercomputer tasks can be done with quantum computing a lot better. Whether AI can actually help with that, not sure yet immediately. Certainly we are making our platforms available for climate change. um, the reason for that is that I think the problem is more mathematical than intelligence, because what you have to really do is, maybe if this causal inference stuff comes out, develops a lot further, maybe then AI will have some of those capabilities as well. Right now it feels a lot more like a mathematical model, and being able to make your mathematical model to be a lot more complete feels like it. But again, we are AI is like a tool which some experts can apply it in a particular way to a problem and get amazing results. But we are just making our platform available to a lot of these agencies if they want to do what they want to do with it. But we don't have any pointed focus ourselves right now. But it's a real issue. What should I say? It's a real issue.
That's great. Gurdeep, we only have a few minutes left. And so I'm going to shift from AI and talk to your experience within this large technology giant for the last, what is it now, 20 years now, I think,
Yeah.
28 years right there, right? So what was your most memorable moment in these last 3 decades of your work at Microsoft?
I'll start by saying that I really got very, very lucky, just from a timing perspective, where this industry was really taking off. And frankly, coming to Microsoft at a time when the company only had one thing, it was called DOS, MS-DOS. And I came to the company, and frankly, the only reason I joined Microsoft is because when I interviewed here, it was very clear to me, even as a fairly green, that these guys are on to something pretty amazing. And I joined Microsoft in 1990, and just before Windows 3.0 shipped, and so on and so forth. So I've been very, very fortunate. But even if I look back across all those amazing years, the one moment which sticks out is in 2014. There is a conference called the Code Conference, or Recode is the thing, and they have this Code Conference. And that is the year when Satya had just become the CEO. And so he wanted to have a really big moment at the Code Conference. His first coming out public appearance. Walt Mossberg was going to interview him. Kara Swisher and Walt Mossberg were going to interview him. And so we were brainstorming, and what is the big thing that Microsoft can show which will really wow the world? And we decided we were going to show something the world had never seen before, which is a conversation on Skype. So I'm with video and audio on Skype talking to another person. I'm speaking English and they're speaking German, and we're having a conversation in real time. So it was one of the most nerve-wracking demos I've ever done. But I was on stage, um, and I did that demo, and that got 1 billion impressions within a couple of days around the world. Every news, uh, every news channel, I was interviewed by Time, New York Times, CNN, every channel around the world actually covered that particular technology moment because it was magical. It was something which humans had never seen before. Humans, I mean, in the history of that is probably my most amazing moment. I don't think I will have another one in my life like that. Um, but but it was and it was an AI moment too, because for the first time we had speech recognition, speech language translation, and speech synthesis all tethered in a real time loop. Because when you're having a conversation, it has to feel relatively natural. And that, of course, then developed into a lot of these capabilities these systems have today. So anyway, that was my moment.
That's wonderful, Gurdeep. So, what is really amazing about that story to me, because we are now talking to the BIT Alumni Association, is imagine 1987, you throw your graduation hat in the air and you walk out of those gates. You remember those concrete gates, and 27 years later, you're standing on the stage with Satya Nadella in the audience and Walt Mossberg and all of these people and Wall Street Journal interviewing. Can you imagine having, in 1987, walking through those gates, having this moment?
I mean, I couldn't imagine it then, and I couldn't imagine it then. I think my only this thing would be I've just been very very fortunate, to have the career that I've had, to have the opportunities that I've had. The only thing, I will, if I can give it as a, bits of advice for folks who are starting out their career, there are two or three things which really matter, man. Number one, stay earnest. If you dedicate yourself, put in as much effort and energy towards doing this, whatever you do, always keep the bigger picture in mind. Why you here, what kind of impact you want to have, what is your service. Okay, that's a very important picture. And stay humble. Life is a long, crazy journey, and we've all been through ups and downs, but there are few things which will always serve you. And so stay earnest, do good, or be in the spirit of doing good, and stay humble. And I think those are the only things I can leave for you guys. And not that I've necessarily been able to do all these things all the time consistently, but that's the only thing you can control, and everything else is fate. And I wish all of you to have the same fate or better than I did, and then you'll do great. So
Total goosebumps, Gurdeep. There, you just like made the day. And so I think it's time to sign off. Thank you, Gurdeep, for this wonderful presentation. I also, a couple of things. One is, can you share that ethics document so we can share it among our group? I think
sure.
that's a very important document. And I wish you more 2014 moments, because I think you're on this trajectory where I think AI is going to be much bigger than Skype and conversational interfaces. And I wish that, it'll be great to see a fellow BITian at the helm of this. And I'm sure that the young people watching this are thinking, one day I'm going to do this to have impact on millions of people's lives.
Thank you.
Thank you. Thank you so much. Thanks, everybody. Thanks for all the questions. We'll have another one soon. More information about that coming through. Thank you all to all the organizers, BitMA Core, Sharath, Subhash, all of the people who made this happen. And have a good
Thanks,
week.
Anijo, for
Thank
really
you.
being a great host. So
Great. Thank you. Bye-bye.
Bye-bye.